Hi Year 12. Today we're looking at binomial distribution. So the binomial distribution is an extension of the Bernoulli distribution that comes from running multiple Bernoulli trials, which are experiments that have only two outcomes, success and failure. So properties of a binomial distribution is that there is a fixed number of trials. Each trial only has two outcomes, success and failure, with probability P and Q equals 1 minus P respectively. Each trial is independent and the probabilities are the same for each trial. The binomial random variable is the number of successes from n Bernoulli trials. So we want to state for this first example whether each random variable describes a binomial distribution. So the number of tails when tossing a coin 50 times. So what we want to think to ourselves here is the number of tails when tossing a coin, can we get success and failure out of that? And the answer to that is yes. So this is a Bernoulli binomial random variable, a binomial distribution, sorry. Then we have the number of red cards selected when 8 cards are selected at random from a bag of coloured cards with replacement. So this is yes, it's either success or failure. So it's going to be a binomial distribution. This is because we are putting the cards back so that the probability stays the same, and that hits that last dot point there, whereas when it's without replacement, the probability is changing each time. So it's a no. So we can find the probability of all successes and all failures in multiple events in a binomial distribution. In permutations and combinations, we found the link between Pascal's triangle and coefficients in the expansion of binomial products. So the number of outcomes in probability is given by coefficients NCR. So the probabilities in a binomial distribution, if P is the probability of success, then the probability of R successes in N independent trials is given by the probability of X equals NCR P to the power of R of 1 minus P to the power of N minus R. So this can also look like another version of NCR, P to the power of R, 1 minus P to the power of N minus R. Now it's important to note that this formula here is on the reference sheet for you. So X is the random variable of the binomial distribution, and this is sometimes written as X bin NP. So for our example 2, we want to, when tossing a coin 5 times, find the number of ways of tossing 3 heads. So for this, we are finding the probability of X equals 3. So using the formula above, we have that N is our 5 because we have 5 times that we're tossing. Choose 3 because we want 3 heads, and then we have our probability of tossing a coin is a half, so our P is a half to the power of 3 because we want 3 heads, and then we go a half to the power of our N of 5 minus 3. So what this looks like is 5 choose 3 of a half to the power of 3 bracket a half to the power of 2. We then put this into our calculator to get 5 over 16. Now we want to know, when tossing a coin 5 times, find the number of ways of tossing 4 tails. So we're finding the probability of X equals 4. And so in this case, we have 5 coins that we're tossing, and the success is R 4 times. So it's going to be a half, because the probability of tossing a tail on a coin is a half to the power of 4 bracket 1 minus the probability, so that's also a half, equals 5 minus 4. So this equals 5 choose 4 a half to the power of 4 bracket a half to the power of 1. When we put this into our calculator, we get 5 over 32. Now we want to find the number of ways of tossing 2 heads. That's the probability of X equals 2. So this is 5 choose 2, a half to the power of 2, and a half to the power of 5 minus 2. So 5 choose 2, a half to the power of 2, a half to the power of 3, and this equals 5 over 16 when we put it into our calculator. For example, D of this, we want at least 4 heads. So what this means is the probability of x is greater than or equal to 4. So this is going to be the probability that x equals 4 plus the probability that x equals 5. So what we have here is we need to find what x equals 4 when we get 4 heads. So this is 5 choose 4. A half to the power of 4, and it will be a half to the power of 5 minus 4, which is 1. When we put that into our calculator, we get 5 over 32. Then we need to find the probability that x equals 5. So that means we get 5 heads, so 5 choose 5. So it will be a half to the power of 5 and a half to the power of 0. When we put that into our calculator, we get 1 over 32. So the probability that x is greater than or equal to 4 is equal to the probability that x is equal to 4 plus the probability that x is equal to 5. So this will be 5 on 32 plus 1 on 32, which equals 6 on 32, which simplifies down to be 3 over 16. For example, E, we want fewer than 2 tails. So it's the probability that x is less than 2. It's not equal to 2, it's fewer than 2. So this means that it's the probability that x equals 0 plus the probability that x equals 1. So therefore, the probability that x equals 0, so getting 0 tails, will be 5 choose 0, a half to the power of 0, times a half to the power of 5. And what that equals is 1 over 32. And then we need to find the probability that x equals 1. So this is 5 choose 1, a half to the power of 1 times a half to the power of 5 minus 1, which is 4. And what this equals to is 5 over 32. So therefore, the probability that x is less than 2 is equal to the probability that x equals 0 plus the probability that x equals 1, which is 1 on 32 plus 5 on 32. So what this equals to is 6 on 32, which is 3 on 16. For example 3, we have a hydrangea plant has a probability of 1/3 of producing white flowers. If 4 plants are grown, find the probability that only 1 plant will produce white flowers. So we're finding the probability that x equals 1 using the same formula as we did up above. So we have 4 plants that we're choosing from, and only 1 of them will produce white flowers. Now it's telling us here that in the question that the probability of getting white flowers is 1/3. So that means our probability here is going to be 1/3 to the power of 1, and then it will be 1 minus 1/3 here to the power of 4 minus 1. So what the formula that this came from was the probability of x equals NCR, probability of R times 1 minus P to the power of N minus R. Just for a recap, so 4 choose 1 is just 4 choose 1, 1/3 to the power of 1, and then this is 2/3 to the power of 3. We put this into our calculator and we get 32 over 81, and that doesn't simplify any further. Example 4, we have Maria tosses 8 coins. Find the probability that she tosses 5 heads. So again, we're using that same formula of the probability of x equals NCR P to the power of R, 1 minus P to the power of N minus R. So the probability that x equals, now we want 5 heads. We have 8 coins that we're tossing. We want to choose 5. The probability of tossing a coin is 1/2 to the power of getting our 5 successes that we want, and then it will be 1/2 to the power of 8 minus 5 here. So this will be 8C5, 1/2 to the power of 5, 1/2 to the power of 3 equals 7 over 32. Then, for example 5, we have a certain type of machine in a car assembly has an average probability of 0.1 of breaking down. If the assembly plant has 8 of these machines, what is the probability, correct to 3 decimal places, that at least 6 will be in good working order at any time? So again, we want to use the probability that x equals NCR, probability of R, 1 minus the probability of N minus R. From this question, we have that breaking down has a probability of 0.1. So not breaking down, or in other words, sorry, in good working order. So good working order will be 1 minus the probability of breaking down, which is 0.9. Now, we want that at least 6 will be in good working order. So we'll have the probability that x is greater than or equal to 6, which equals the probability that x equals 6, and we have 8 cars. So the probability of x equals 7, and the probability that x equals 8. So we can do this all at once. So the probability that x equals 6 is 8c6, 0.9 to the power of 6 times, or breaking down is our other one, so 0.1 to the power of 2, plus the probability that x equals 7 is 827, 0.9 to the power of 7, 0.1 to the power of 1, plus the probability that x equals 8 is 8c8, 0.9 to the power of 8, 0.1 to the power of 0. And when we put this all into our calculator, we get 0.96190821. And let's round that. It says correct to 3 decimal places in our question, so 0.962 is